Hi everyone, this is Asma Mushtaq from the EEVIBES, and in this video lecture I'm going to explain how we can use the transistor as a switch. We usually use the transistor as a switch when we operate it into the common emitter configuration. And what happens in the common emitter configuration? The emitter terminal is grounded while the collector terminal is connected with the VCC via resistor RC, and the base is connected via resistor RB where you supply the input voltages basically. Fine. In this case, the VCE, which are the voltages from the collector to emitter, are the output voltages. Okay. Before starting the discussion how we use the transistor as a switch, let's have a look at the output characteristic curves of the transistor in the common emitter configuration, which is actually the plot between the VCE and the IC for the different values of the input current, which is the base current. Fine. On the characteristic curves, we identify the three regions of operations. Let me highlight them. The first one region that I am highlighting is known as the saturation region. Fine. And in this region of operation, IC is the maximum current that flows through the transistor, which can be determined by using the formula VCC over RC. Okay, while if you look at the x-axis curve, you can see that VCE is approximately equal to 0 volts. Fine. The second region of operation is when IB is approximately equal to 0 ampere and only a small leakage current will flow across the IC. In that case, we say that IB is equal to 0 volt, 0 ampere. And from here we can see IC, which is equal to beta times of IB, is also equal to 0. Now from the circuit of the transistor, we know that the VCE is equal to VCC minus IC into RC. So when this term becomes 0, then we say that VCE will be equal to VCC. So this is the identification over here. Here you will have VCE approximately equal to VCC. Fine. The third region is the linear region where the transistor becomes horizontally straight lines, and in this region you operate the transistor as an amplifier. While when you operate the transistor between the cutoff region and the saturation region, then it can act as a switch. So here the transistor will be off since no base current will be flowing in the circuitry, while in this case the transistor will be in the on state, and you will say that the maximum current is flowing in this case. Fine. So assume that you are given the information like RC is equal to 1 kilo ohms while VCC is equal to 10 volt, V in, which is basically the input voltages, and when V in is equal to 0 volt, then what will happen? Obviously there will be no base current, hence IC will be equal to 0 amperes, and the collector to emitter voltages or the output voltages, which is VCE in this case, will be equal to VCC and 10 volt. Fine. Now we have to suppose we have to determine the minimum value of the base current required in order to send the transistor into the saturation, and for that we need to determine first IC saturation. So what is IC saturation? It can be found by using the formula VCC over RC, which is equal to 10 volt divided by 1K. So this implies it is equal to 10 milliamperes. Now assume that beta DC of this transistor is equal to 200. From here, I can find the minimum base current required to send the transistor into saturation, which is equal to IC saturation divided by beta DC. So 10 milliamperes divided by 200 will give me 50 microampere base current. This is the minimum current required in order to send the transistor into the saturation region. Fine. Now, what should be the value of the RB when V in is equal to 5 volts? So if I do set V in is equal to 5 volts, then I have to determine the value of the base resistance. For that, what I will do, the voltages across the VRB can be found by using the formula V in minus VBE, which is the base to emitter voltages, and these are usually equal to 0.7 volts. So VRB will be equal to 4.3 volts. Fine. And hence RB maximum will correspond to the minimum base current, and it can be found by using VRB divided by IB minimum. Since there is the inverse relation between the resistance and the current, so 4.3 volts divided by 50 microamperes gives 86 kilo ohms resistor at the base terminal. So generally what happens when the transistor is used as a switch, then in the off state the transistor is not conducting, and we can replace it with an open circuit, and output voltages VCE will be equal to VCC. While when the transistor is in the conduction state, we can replace it with a short circuit, and in that case output voltages VCE will be equal to 0 volt approximately, or 0.02 volts. Thank you for watching.